Okay, let's see now. 284. What substitution would I like to use? I guess I would want to go with u equals cos theta, because that would mean du equals minus sine theta d theta. So minus du would be sine theta d theta. So the question would become u 1 minus u power 99 du. Huh. Yeah. Has that really helped, actually? Hmm. Well, it's helped, I suppose, but I'm going to need another substitution. I think I'm going to have to say v equals 1 minus u. So that means dv will equal minus du. dv equals minus du. So that means minus dv equals du. So now the integration becomes, and the u is actually 1 minus v times v power 99, and then du is minus dv. So then that would become 1 times v times minus, so that's minus v power 99, and then minus times minus is plus v power 100 dv. So then that would equal, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, plus c. And then that minus v, that becomes minus 1 minus u, which is cos theta, power 100 over 100, plus v, which is 1 minus cos theta, power 101 over 101 plus c. All right, 285 now. What substitution to use now? Well, again, I'm going to go with u equals cos theta, because then you'll get du d theta equals minus sine theta. So minus du would equal sine theta d theta. So then the integration becomes 1 minus u cubed power 10 u squared minus du. So the same trick again, v equals 1 minus u cubed. That means dv du equals minus 3u squared. So dv equals minus 3u squared du, which is good because I have u squared du and a minus. So if I just divide by 3, I can get dv equals minus u squared du, which is what I have, minus u squared du. So then the integration becomes v power 10 dv over 3, which becomes 1/3 v power 11 divided by 11 plus c, which would be 1 over 33 v, which is 1 minus u, which is cos cubed, power 11 plus c. Ooh-wee. Okay. Now I can check that answer at least. Yep. That one looks right. Okay. Now on to 286. 286. Okay. Gonna going to be the same trick again. Let u equal... Now I could take out cos here. Would that help me? And that would leave me with cos minus 2. I don't think so. U equals cos theta. Well, we've seen this already now. So minus du equals sine theta d theta. So then the question becomes cos theta minus 1. That's u minus 1. U squared minus 2u cubed, and then sine theta d theta, that's du with a minus. So then that becomes 1 minus u squared but you see, I feel like I should take the u out. So that would be u minus 2 cubed. And you know, it's only a cube, so do I want to expand it? Do I want to expand it or use some fancy substitution? No, I think I can see what's happening here. So I now say let v equals u squared minus 2u. So that means dv du would be 2u minus 2. Or in other words, 2u minus 1 du. So that means dv over 2 is u minus 1 du, which is exactly what I have here. So this integration becomes minus integration of v cubed dv over 2. So that would equal minus a half v power 4 over 4 plus c, which equals minus 1 over 8 v, which is u squared. So that's cos squared theta minus 2 cos theta power 4 plus c. Yeah, okay. Now, 287 looks very interesting. 3 sine squared 6. Wonder if there's something smart we could do here. I wonder if there's something smart we can do here. Something fancy. Fancy pants. Sip of coffee and think. So. Note the derivative of sine theta d theta is equal to cos theta the derivative of sine squared theta d theta is 2 sine theta cos theta. See, I'm trying to do something fancy rather than a double substitution, just to change it up a little bit. And I noticed that the derivative of sine cubed theta minus 3 sine squared theta cubed over d theta over d sine theta. So let me just space that out a little bit. So note the derivative of sine cubed theta minus 3 sine squared theta cubed over d sine theta. So if you just pretend sine theta is like a variable like x, then this just becomes the chain rule, which is bring down the power, reduce the power by 1, sine cubed theta, minus 3 sine squared theta squared. And you know what? I didn't even make enough space. And then times 3 sine squared theta minus 6 sine theta. So this is a little bit like x cubed becoming 3x squared and 3x squared becoming 6x. And this is remarkably similar to what we have. In fact, if I just take the 3 out, put the 3 here, and then put it at the front, I'll get a 9. So you can see that this sine cubed minus 3 sine squared, sine cubed minus 3, oh, okay, yeah, so that's that d theta. Could I make use of this? Forgot about the cos theta here. I could bring this up to the other side, d sine theta. So what have I got matched up? I've got this guy, which is that guy. So then if I divide these two under, actually, okay, so maybe, I'm just trying something different here, just for the sake of interest here. If I divide by this 9 here, so I still have d sine theta, and then I'll have the 9 sine cubed theta minus 3 sine squared theta squared, and I sub that in, this piece in, so this integration would become sine squared theta minus 2 sine theta, and then you have the cubed sine cubed theta minus 3 sine squared theta cubed cos theta d theta, and I'm replacing this guy here with d sine cubed theta minus 3 sine squared theta cubed. Sorry, my handwriting's a bit messy here. That's cubed. All over d sine theta 9 sine cubed theta minus 3 sine squared theta squared. So that would cancel with that. Sorry, not with that. With that. And then if d sine theta d theta is cos theta, then d sine theta cos theta, d sine theta equals cos theta d theta. So those two would cancel with that. So you would just be left with sine cubed theta minus 3 sine squared theta d sine cubed theta minus 3 sine squared theta cubed so that's a little bit like x dx cubed. And just remember, dx cubed dx equals 3x squared. So that means dx cubed is 3x squared dx. Where, okay, so then that would mean x dx cubed would be 3x cubed dx. So this could be written as 3. I might as well just integrate it then. So if you integrate 3x cubed, if you integrate x dx cubed, that's like integrating 3x cubed dx, which would be 3x4 over 4. So that would be 3/4 sine cubed theta minus 3 sine squared theta power 4 plus c. Oh man, I'd be so happy if this is right. Ooh, I'm close. 3/4 sine cubed minus 3 sine squared power 4 plus c. I have lost something. Something small. Oh, my 9. Completely forgot about my 9. So that's 1 over 9. So that's 1 over 9. So 3 goes into 9 3 times. So that's 1 over 12 sine cubed theta minus 3 sine squared theta power 4 plus c. Yeah, okay. So I wanted to try something a little bit different, a little bit quote unquote fancy. But I think personally, I probably would just stick to double substitutions in future. Okay, 280, 287.